this is Britt Caswell with another example video. In this video, I will be covering example 3 from section 3-6 in the SavvasRealize Algebra 1 textbook. So, in this example we are looking at how to interpret residual plots. So in our textbook it says that there's student enrollment at the Blue Sky Flight School. And it's over 8 years. Okay, so they have our 8 years of data right here. The owner used linear regression to determine the line of best fit. And the equation for the line of best fit is shown here. And we want to figure out how well does this linear model fit the data. Alright? Now this is what I call eyeball mathematics. Okay? We would just look at the R value, right? So in your book, it actually shows you how to get the predicted value and the residual. So I'm going to tell you how they did this. So they started with the year and the students. So once they got their line of best fit, then what they did was they did some predictions. So they were taking these years and plugging them into the equation to get this predicted value. Okay? So for example, if I plug in 0 for x, this term goes away and I get 1208. Okay? So then remember, I was describing a residual as the distance or the difference between the actual and the predicted value, right? I'm going to write that here. So what they did was they did a subtraction. So they took the actual value and they subtracted the predicted value. And so that created the residuals that you see here. So what they do with this residual value is they create some tables. Alright, now this is the original data and this is the trend line. So then what they did was they calculated those residuals and they put it on this line here. And what we're doing is we are looking for all these distances from the point to this axis. So what I would do is I'd say, well, for example, this point here at 2 kind of counteracts this point here at 5. Alright, and this residual, okay, it's 1, 2, 3, 4, 5 boxes down. Well, this one's 3 boxes. Here's a half a box, and 1 box, plus another half. So this one has about half a box more in terms of distance from the line than the ones below it. So I would say this one's fairly well distributed, because if I add up these distances, here's 2.5, 0.5, 2.5, 1.5. Okay, so there's our distances there. And then on these ones, so this one was 5, right? This one's almost at 2.5. We'll call it 2.5. So if we can add up these distances, which mind you, I put them counting boxes, whereas these are counting by tens. I didn't want to have to count by tens. So just be aware of that. So 2.5, 3, 4, 5, 6. So this one has a total of 7. And this one had 7.5 below. So as long as these two values, these two distances, are about the same, that's how you know that your residual is pretty good. Okay? The computer will do that for you. That's what all that R statistic stuff was from our last video. Okay? So then it says, the owner of the Horizon Flight School also created a scatter plot and calculated the line of best fit for her enrollment data that's shown on the table. So this is where they wanted you to use Desmos in order to find the residual plot. So I'm going to show you the button that's on Desmos as to how to do that, okay? So notice they created the table, and then down here they're going to have y1 tilde m x1 plus b. Okay, that's what we're used to seeing. Now there's a button that shows up in the little table, and it'll say plot. And so if you hit that plot button, what it's going to do is it's going to create this E1 button, or this E1 column. The E1s, these are your residuals. And it shows up here on our table. Alright, I'm just looking back from our previous notes from my screenshots to see if I could show you that button. Yeah, so right there, see? So if they hit that E1 plot that's on Desmos, that's what'll create the third column, and it'll put all the dots down here to show the distance from the line. Okay. Let's see. And so this is asking. It says find the residuals. So here's our residuals, and here's the plot. So if I look at this, well, this one's kind of far down. He'll probably match this guy a little bit. These ones are on the line, so they don't really matter. And then if you notice, there's 2 above the line and 2 below the line. So this one fits the data pretty well. Which it should, right? Because the computer, okay, they actually use Desmos for this. The computer calculates it for them. So it figured out the smallest residuals possible with their line. But there we are. So that is that's our discussion on residuals. All right. Again, this was interpreting the residual plots. Until next time.